Hey guys, welcome back to the laboratory. In this video, we are looking at the group 1 elements, commonly referred to as the alkali metals. By the end of this video, you should be able to identify the main properties of the alkali metals, describe how the alkali metals react with water, and explain the different reactivities of the alkali metals. So, let's go. The alkali metals are located in group 1 of the periodic table, therefore indicating that each of these elements have just one electron on their outermost electron shell. As a result of having the same number of electrons on their outermost shell, the alkali metals have very similar chemical and physical properties, some of which are not typical of common metals. To begin with, the alkali metals have very low melting and boiling points, and these values decrease as you move down the group. For example, lithium has a melting point of 180 degrees Celsius, and cesium has a melting point of just 28 degrees Celsius, in comparison to your typical metals which have much higher melting and boiling points, such as iron, which melts at 1540 degrees Celsius. The alkali metals are also very soft and can be easily cut with a knife. As you move down the group, each metal becomes softer and therefore easier to cut. As well as being soft, the alkali metals also have very low densities, with lithium, sodium and potassium being so low in density that they are able to float on water. The density of each alkali metal increases as you move down the group. In addition to their unique physical properties, the alkali metals are also very reactive, with each alkali becoming increasingly more reactive as you move down the group. This trend in reactivity is explained by the interaction between subatomic particles within the atom, namely the protons and electrons. Because of the overall positive charge in the nucleus of an atom, there is a natural force of attraction between the nucleus and the electrons, seeing as they are of the opposite charge. Now remember, when an atom of an element is reacting, it is doing so because it wants to achieve a full outer shell. The alkali metals achieve this by losing their outermost electron and becoming +1 ions. As the atoms of the alkali metals increase in size, the distance between the nucleus and the outermost electron increases too, and so the attraction between them becomes weaker. As the attraction weakens, it becomes easier for the alkali metals to lose this outermost electron and therefore react with other elements. This explains why the alkalis become more reactive as you move down the group. As it becomes easier for the alkali metals to lose this outermost electron, it also becomes easier for them to react. We can use the concept of Wi-Fi to better help your understanding of this concept. Generally speaking, the closer you are to a Wi-Fi router, the stronger your connection, and thus, the more difficult it is for you to disconnect. However, as your distance from the router increases, the connection strength weakens, therefore making it easier for you to disconnect. In this diagram, person A would have the strongest connection to the Wi-Fi because they are closest to it, therefore making it harder for person A to disconnect. This analogy can be used to reflect the interaction between the nucleus and the outermost electron in an atom of lithium, therefore explaining why it is the least reactive of the alkali metals. In contrast, person C would have the weakest connection to the Wi-Fi because they are furthest from it, therefore making it easier for them to disconnect. This analogy can be used to reflect the interaction between the nucleus and the outermost electron in an atom of cesium, therefore explaining why it's the most reactive of the alkali metals. The increasing reactivity of the group 1 elements is demonstrated when lithium, sodium and potassium are reacted with water. When the alkali metals react with water, the products of the reaction are a metal hydroxide and hydrogen gas. Lithium is the least reactive of the three. When lithium reacts with water, the products of the reaction are lithium hydroxide and hydrogen gas. Due to its low density, the lithium metal floats across the surface of the water as bubbles of hydrogen gas are formed. Sodium, which is slightly more reactive than lithium, reacts with water to form sodium hydroxide and hydrogen. Similar to lithium, Sodium's low density means that it floats across the surface of the water during the reaction. However, this time, the reaction is slightly more fierce. The sodium fizzes up into a ball and whizzes across the surface of the water. The strongest reaction of the three is seen when potassium is added to water. This time, the products of the reaction are potassium hydroxide and hydrogen. Similar to lithium and sodium, the potassium floats. Only this time, it bursts into a flame and fiercely bubbles about the water surface. All the solutions produced as a result of these reactions are alkaline and would turn a purplish colour if a universal indicator were to be added. This explains why the group 1 metals are commonly known as the alkali metals. Here's an example of a past paper question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Lithium, sodium and potassium are reactive metals in group 1 of the periodic table. Explain, in terms of their electronic configurations, the increase in reactivity from lithium to sodium to potassium. As always, the question has provided us with a plethora of information that we can use when writing our answer. To begin with, we have been informed that all the named elements are located in group 1 of the periodic table, therefore telling us they all have one electron in their outermost shell that must be lost when they are reacting with other elements. As we move down the group from lithium to sodium and then potassium, the atom will increase in size. As the atom increases in size, the distance between the outermost electron and the nucleus increases too, which in turn weakens the attraction between the two and makes it easier for the outermost electron to be lost. So, for our first marking point, we need to state that the atoms become larger as you move down the group, which therefore increases the distance between the outer electrons and the nucleus. The second marking point is for then explaining that the distance makes it easier for the outer shell electron to be lost. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!